My name is Pavel. I will say a few words about the checkpoint restore stuff we've done at Parallels. So the whole idea about checkpoint restore and the first implementation at Parallels appeared with the OpenVZ project. OpenVZ project is about providing containers on Linux for users, and one of the features of that was containers live migration feature, with which we moved containers without stopping them between two nodes. And since one of the goals of OpenVZ project was to provide containers functionality upstream, someday we decided to start with upstreaming the checkpoint restore. And the first attempt, which was done not only by us, was on the kernel side. So we tried to come up with a set of kernel patches, provided checkpoint restore API for the user space to dump full state of process, pull it out of the kernel, save it somehow on disk, and then restore process out of the information. This approach was not accepted by the kernel community due to big complexity and intrusiveness into the kernel. So we decided to do it on the user space side, and so far we seem to be quite successful with that. The latest release we have is 0.7. It supports x86 64 bits. It supports ARM, both 32 and 64 bits. And it can save state and restore state of pretty much everything typical applications use. Memory files, Unix sockets, UDP sockets. We also can live migrate established TCP connections, and of course containers, since it's our primary interest in that. The nicest thing about this all is that version 0.7 works over unmodified Linux 3.11. All you need is just turn some configuration knobs on, and you'll have all CRIU can, including live migration and similar stuff. We do testing internally. We have a huge set of atomic tests which check that all the kernel APIs are supported, but from time to time we take some real life software and check how CRIU works with them. So far we have checked quite a lot of things, like various services, for example Apache, MySQL, system services, compilers, Java, lots of stuff with VNC and command line tools.
How much kernel code have you gotten rid of that you used to carry around in your private patches?
30% of the average patches.
Yeah, 1/3.
Yeah.
So we basically 1/3, but that's code that was never in the kernel, that was in our private patches, so yeah. What's that? How much of the code did we get rid of by doing it in user space instead of kernel space? So if you compare it to the OpenVZ kernel code, which originally had kernel level checkpoint restore, it's about the total size of the OpenVZ patch for, I think, 2632 is about just somewhere short of 100,000 lines. 33,000 of those lines are roughly in kernel checkpoint restore that we just threw away.
Yeah. Something like that. At Parallels, we've basically started with only two usage scenarios for checkpoint restore. They were live migration and kernel upgrades without reboot. Live migration is used and can be used by anybody else for example, load balancing in a cluster, for power saving, for pulling nodes out for maintenance and similar stuff. But while the project was growing, people came up to us with various other scenarios. For example, some guys already use CRIU to speed up starting of Java stuff. It starts slowly but restores from images up to 100 times faster. HPC people are very interested in periodic snapshots, so in case they perform some computation that lasts, I don't know, several days, and they have a power outage on Sunday. They don't have to recompute the whole stuff from scratch. We've seen scenarios for enhancing debugging and testing, and a lot more. An API for CRIU is twofold. From the very beginning, CRIU was a command line tool, which included and now includes several top-level actions, dump and restore, basic stuff for getting state and restore from it. The pre-dump and page servers are two commands that can speed live migration up. When you're doing live migration, what you want is to copy the whole state from one machine to another. But in order to have the state consistent, you have to keep the tasks frozen while doing this transfer. If the amount of memory applications used is huge, it can last minutes, which is not acceptable in most situations. So with page server and pre-dump, we can fetch some memory in advance on another machine without stopping tasks, then stop them, check what has changed, and transfer a significantly smaller amount of data to keep up with the changes. We have a service command for RPC, the next thing, and some exploring stuff like show, which will show the contents of images with the state, and the quite useful thing called check. If you are not sure that the kernel support is up to date, you can run CRIU check. It will tell you what's missing in the kernel. And the second way to use CRIU is using RPC. It's not yet in 0.7. It's scheduled for 0.8 or 1.0 if it will be stable enough at that point. It basically includes CRIU service, which listens on a Unix socket and accepts requests encoded using Google Protocol buffers format. Using one, currently programs can request to dump themselves, for example. And since protobuf bindings exist for a variety of languages, we are not limited with C only, so we can use it with Python, Java, and so on. I have a demo. I'll try to show it to you. So, whoops. Let's try it one more time.
You need the 24 by 768.
You want a mirror output?
I tried the same as, wait a second. There should be, yeah, that's it. Now,
Yes.
like this.
Yes.
Yeah, got it.
Yeah. Okay.
Still slightly cut off. You might need to.
That's okay. So, this terminal runs inside a KVM virtual machine, which is on my laptop. I'll start a VNC server, and from my laptop, connect to it with the VNC viewer. So, what I did is created a TCP connection from my laptop into a virtual machine. I start an X-screen server with a pacman, and what I do next is go into this virtual machine, remove all the images, and you can see there is a TCP connection, as I told, from inside the KVM guest to my laptop. Here is the VNC server plus window manager, Xterm, bash, and the screen server itself. So let's try to dump this guy. Yeah. So also I use a lot of short options. There are long for each of them. What I say here is that I want to dump process starting from PID 9557, put images into directory D, write log file into a dump.log with increased verbosity, and the TCP established key is required because TCP connection should be handled separately, and the user have to say explicitly for CRIU that it's aware of changes that can be done in the system to make it running. So here it is. Processes were dumped and they disappeared. The connection is not here, but the client sees that it just stuck because the connection is blocked with the net filter. Now we can try to, to restore them, right? Let's check. The connection is back here. The processes are back here, and the most interesting thing, yep, it's up and running again. So everything was restored. What is produced by CRIU is a bunch of files, each one containing some information about process. They are all encoded in protocol buffers format. To explore them, you can use the show command, for example, the What's wrong with that? Sorry? Oh, yeah, sorry. Forgot myself. You can explore the images with the show command. Here is the tree of process. We dump all the information about them. Registers, COM, VMAs, all the files that they keep opened, and so on and so forth. So CRIU lives on the CRIU.org site. There is some amount of documentation, a description of the format, a page describing API, both CLI and RPC, and other stuff. Sources sit in Git. In the main branch, we have the Google Plus page where we publish news about the project. To follow up with the discussion, you can also subscribe to the mailing list, and in the below is my email. I currently maintain the project, so you can also ask questions to me. Which one?
Explain. So the title was.
Turn it on.
The title was CRIU and LXC. Explain how CRIU works with containers, LXC, OpenVZ, and everything.
Oh, so I have one. Yeah. So the question, not the question, but the proposal was to describe how CRIU works with LXC. CRIU currently supports namespaces, which means when you provide the PID of a process tree you want to dump, it will check whether this process lives in any set of namespaces and will start dumping them as well. So since both LXC and OpenVZ, VZ control create a plain set of namespaces for a container, CRIU can be used to dump and, of course, restore containers. We have already integrated CRIU into OpenVZ, so you can just take OpenVZ kernel tools, VZ control, and dump and restore containers with a higher level command line tools than CRIU is. You've seen that there are lots of options you have to pass to make it working. With VZ control, it will be as simple as just VZ control dump and the container ID. Sorry? Yeah, it is. The similar thing can be done with LXC. What LXC should do is start CRIU providing it with the PID of a root process, as it's seen from the initial PID namespace, and providing it with the directory where to put images into. After dump, LXC should not after dump, but before restore, LXC should make sure that the file system state is the same as it was after dump, because CRIU cares only about the process state and everything related to that. Any external state, such as file system and, for example, networking configuration on the host side, all this stuff should be pre-configured and prepared by the caller. VZ control does that. It's up to LXC to do the same.
So that's actually more of a challenge than you're letting on, because if you've got a full system container and it has gone and done a bunch of mounting, and someone has to second guess and say what needs to be mounted, right? You're saying you're not really filling the mount state. So when you still have a system container, LXC does a couple mounts, but then it goes through and does a bunch more mounting.
If container lives in its own mount namespace, CRIU will take this namespace mounts into the images. But if your container lives in the same mount namespace as the host does, then yes, you should prepare mounts in advance.
Yeah, my understanding of what you just said is that we need to make sure that the container root file system is perfectly at the same place on disk as it was when you took the snapshot, but everything else from there should be covered by CRIU.
Basically with the very same state, very same files.
Right.
Yeah.
Okay.
You said it will. If it was in its own namespace, it will restore.
It will restore the namespace. You just need to make sure that the root file system and all files that were opened by that container on the host are the same place and are identical.
Yep.
Nice curveball question. What stops you using VZCTL dump on a LXC container?
Basically, with VZCTL, we support both in kernel checkpointing that we traditionally have, and we support CRIU for 3.x kernel. In case we see 3.x kernel, we just call a couple of shell scripts, VZCPT, VZRST, and they call CRIU. And yeah, besides that, we do all the job because it's the same as for the checkpointing that we had before. And by just utilizing these two small shell scripts, we have all the functionality in place. Like, for example, we already have migration capability that takes care about file system migration to the different box. So migration is just another shell script which calls VZCTL and rsync. And that's basically it. I mean, it was quite a short patch to add the support for CRIU.
But the question was actually, I was getting at, was deeper than that. OpenVZ container is slightly different from an LXC container. But is it possible to actually use VZCTL to dump an LXC container, or do the differences actually prevent that?
You mean if the container is to be created by LXC tools? Yeah, I actually haven't tried that, but...
Give me a theoretical guess. Would it be possible?
I guess
yes, it would be. We
Yes.
have tried it manually, actually. We created a container with LXC and dumped.
I'd better try that, but it looks like it's the same container, basically.
So can you give a few examples that these two containers? So you mentioned that there's like the container created by the CRIU and the LXC is different. Can you give some examples like how they're different?
I don't know. I think they're fairly similar, actually.
So I can try to answer that. They're actually extremely similar. The biggest difference, I think, is that they're not on the same place on the file system. We don't use the same config file either, but besides that, we use, I guess, OpenVZ on an unpatched kernel will use the same features as LXC does. The main difference is they're not at the same place, the config is different. But for CRIU, it doesn't matter. That's why it should just work.
So basically, what he's now said is that we can do it today.
Yeah, apparently.
Yep.
All right, so thanks for the talk. We'll take a